I'm Eric Crable, a technical marketing engineer at Xilinx. Thank you for joining me on this quick sprint through one facet of UltraScale Plus FPGA security. Xilinx approaches security in three ways. First, through security features we build directly into the silicon, with enhancements for each new device generation to keep ahead of adversaries and the growing risk they represent. Incidentally, we don't integrate export-controlled or classified features into our silicon, since we're a commercial company with a worldwide customer base. Second is soft IP we provide for users to add to their designs to provide an additional layer of protection after the device enters user mode and starts operation. Third is guidance. For instance, security technical guidance in the form of white papers, user guides, application notes, and direct support. Passive security features are those that are built into the device and do not require you to do anything extra in your design. For example, bitstream decryption and authentication fall into this group. Active security features require you to do something in your design, and active security features come into effect after the device is in user mode. Maybe you aren't using any design security. Is there a way to get started with it? Absolutely, and it's included for free in every UltraScale Plus FPGA. We've had support for encrypted bit streams for several product generations. Using AES-256 with an Effuse key, you can keep your design confidential with this NIST-approved self-authenticating encryption algorithm. AES-256 is a symmetric algorithm, meaning the same key is used for both encryption and decryption. It has advantages in that it's fast, computationally, with a relatively smaller key size. However, the key, which must be held secret, needs to be programmed into the Effuse in the UltraScale Plus FPGA. Once it's stored there, it's well protected, but it means you must trust your contract manufacturer or find ways to program the key without your contract manufacturer in the loop. Starting at the top left of the diagram, you see how the key is programmed by Vivado over JTAG into the Effuse. We'll be looking at that in detail, but know that in higher volumes, other Effuse programming solutions exist. The key is also used by Vivado to encrypt your design file, so that what you're storing in non-volatile memory of the fielded system is encrypted. Encryption prevents an adversary from configuring your device with a different bitstream, nor can they use the encrypted data to configure a different device. Let's look at the design encryption as well as the Effuse programming with the KU9P device on the KCU114 board using Master SPY/4 configuration mode. Since we need a design to make an example, I created a virtual wire project called KU9P AES in Vivado 2016.1. It connects a push button to a light-emitting diode through the KU9P on the KCU114. The contents of the two source files are shown. Since we're learning about encryption, let's explore it interactively through the GUI. After running the design flow through the implementation step, you can access the full set of bitstream settings. Let's open the implemented design. With the implemented design open, click Bitstream Settings. This opens a window to adjust settings with an initial focus on output file types. Click Configure Additional Bitstream Settings to open another window for the additional properties. Look at the Encryption settings group. Enable bitstream encryption and set the location of the encryption key to Effuse. You also need to provide the initial key value. Let's use 0. That's a terrible key I'd never advise anyone use, but whatever key you choose, remember you need to keep it secret. We're done with the additional settings. Click through two OK buttons to return to the implemented design. Save the new properties for the implemented design. Close the implemented design. Click Generate Bitstream in the Flow Navigator. If the design run is out of date, accept the offer to rerun any prior steps. Let's generate a memory configuration file. After approving the settings, Vivado generates the MCS file. Now we're ready to work with hardware. The KCU114 is currently connected to this computer using the USB cable for JTAG and the power is on. Click Open Hardware Manager in the Flow Navigator. Open and connect to the board by clicking Open Target at the top. Since we're using encryption, we need to get both the encrypted bitstream and the key into the hardware. In production, it's typical the encrypted bitstream is pre-programmed into a non-volatile memory, and the key is pre-programmed into the UltraScale plus FPGA. In development and pre-production, though, I expect you're using Vivado, at least for the Effuse programming, and if you're using a SPI or BPI configuration mode, you are also using Vivado for flash programming. In the case where you're using Vivado for both the Effuse programming and the flash programming, the order can matter. As we'll see, when you program the Effuse, you can enable a setting that forces the UltraScale plus FPGA to always use bitstream and decryption, making it impossible to configure with any bitstream not encrypted with your secret key. This keeps presumably unauthorized bitstreams from being loaded, but a side effect of this protection is Vivado cannot load the bitstream it uses for indirect flash programming. So in this case, you must program the flash first and then program the Effuse. Launch the Add Configuration Memory Device dialog by right-clicking on the KU9P in the Hardware Manager window. Select the desired memory device. To start the sequence using the MCS file, click OK. Now let's look at Effuse programming. Xilinx Effuse technology is non-volatile. I was going to call it one-time programmable, but you can actually program it more than once, just that when you program a particular field or control bit, there's no undoing the programming of that particular field or bit that you've programmed. I'm going to show you what you need to know to program Effuse, but will not execute the programming step. Earlier, I used a zero-valued encryption key so I can demonstrate configuration with an encrypted bitstream using the default unprogrammed Effuse values, which happen to be 0. Right-click on the KU9P device listed in the Hardware Manager and select Program Effuse Registers. This launches a wizard to guide you through the process. Click through the welcome screen to the first settings. Here, you would load the NKY file generated by write bitstream, after which you see the AES key value populated. To enable programming of the key, check the box. Proceed to the next settings screen. There is additional Effuse for application-specific user fields not related to encryption, so click through to the next settings screen. This screen shows control register settings, a bunch of disables. You can selectively disable reads and writes of the encryption and authentication keys, the application-specific user fields, the security settings, and the control register itself. Generally, if you don't want an adversary to play with your settings, it's prudent to disable all of these, except perhaps the application-specific user fields. To disable any of these, check the box and then click through to the next settings screen. This screen shows security register settings. Let's talk about each of them. Config AES only, when programmed, only allows encrypted bitstreams, thereby blocking use of unencrypted bitstreams. This can be important if you want to block an attacker from being able to load a malicious, unencrypted bitstream. A side effect, though, is that it also prevents Xilinx from loading bitstreams like those used for indirect flash programming and diagnostic checks. Effuse key only, when programmed, selects the key source as coming from Effuse only. RSA auth is to enable RSA authentication, a feature that can be used with encryption, but we aren't covering it today. Scan disable is to disable JTAG access to the device, something to consider if you want to prevent an adversary from poking around on JTAG, which is a common attack vector. Finally, programming crypt disable will disable the AES decryptor in the device. Normally you would not disable it, but this does have some advanced uses. Clicking through to the next screen gives me an Effuse programming summary. Vivado recognizes I've reached this point without making any programming selections, so I'm canceling back to the Hardware Manager without programming the Effuse. Now let's take a look at the hardware and configure it with the encrypted bitstream and the default unprogrammed Effuse values. I've turned the board off and disconnected everything but the power supply. When I turn the board back on, what I expect is the UltraScale plus FPGA will configure by master SPI by 4 with my encrypted bitstream. The done pin will go high, observable on this LED here, and my design will work using this button and this LED. Done went high, and my design is working with my encrypted bitstream. Now you've seen UltraScale Plus FPGA bitstream encryption using AES and Effuse is free and easy. There's no reason to leave your design front door unlocked. If you aren't using security, consider this free and easy place to start. This how-to was for the KCU114. The Flash programming flow applies to any board supporting Master SPI with an UltraScale Plus or UltraScale FPGA, and the Effuse programming flow is applicable to both those FPGA families regardless of configuration mode. Thanks for spending your time with me.